Okay, so the last section we're going to look at for this week is 3.5. It's on finding roots again of polynomials. But this time, when we have a problem like this, it says find the roots, they might come out imaginary. So we can still use factoring, we can still use synthetic division, we can still use rational root theorem, we can still use all that stuff. But if you don't remember how to work with imaginaries, we're going to get stuck in arithmetic. All right, so we don't want to get stuck with that, so let's review complex arithmetic. So remember that if a number is a root, that number tells you where it crosses the x-axis if it's a real number. So like if I had a problem like f of x equals 3x minus 6, the root there is 2, because if I plug in 2 for x, I'll get 0 for the answer. Since the root is 2, if I look on my graph at the point 2, 0, that's going to be where it crosses the x-axis. So when you're looking at the root, I just want you to understand it tells you where it crosses the x-axis. Any question on that? The root tells you where it crosses the x-axis. Now, what if the root wasn't a 2? What if the root was an imaginary number? Then the problem with that is you are not going to see it ever cross the x-axis, and the calculator cannot give you the answer. So if a polynomial does not cross the x-axis, it doesn't mean that there aren't any roots. There still are roots. What that means is the roots are not real. And if a number isn't real, then it's imaginary. Okay? So let's look at an example like this one. Let me graph y equals x squared plus 1. So give that a second to graph. If I graph y equals x squared plus 1, we're going to see that it's a parabola, and it's been shifted up 1 unit. Does that graph cross the x-axis? No. Then does that mean that there are no roots? No, it doesn't mean that at all. It means there are no real roots, but there are imaginary roots. So is there any question why, looking at that picture, there are no real roots? Okay. So now, let's look at what would happen if we tried to solve this problem. Let's try to set that equal to 0, because that's how you find roots. You set your equation equal to 0. If I do that, what would be my first step on both sides to get x by itself?
Subtract 1.
I would subtract 1. That's gone. And what would be my second step?
Square root.
Okay, now we have a problem. Squaring and square rooting cancels. But I'm trying to take the square root of what kind of number? A negative. And if you go on your calculator and try to type the square root of a negative, it doesn't tell you that it can't. Well, let me set this the way yours is probably set. When I type in the square root of -1, it doesn't tell me that it can't do it. It just says the answer that you're going to get is not real. So if the calculator isn't set to show imaginary numbers, then it'll always give you that error. It's kind of warning you. You're about to get an answer that's not real. Are you sure you want to do that? And sometimes we are, yeah. Sometimes imaginary answers are part of the problem. And today they will be. So what I'm going to do on my calculator is press mode. And instead of having the calculator use the real number system, I'm going to have it use the second option, which is real and imaginary. Now it'll use both. So when I set my calculator, press mode, and set my calculator to use reals and imaginaries. Now when I type in the square root of negative 1, it doesn't warn me anymore. It just tells me the answer is I. It's assuming that you know what that means. So now we're going to talk about what does I mean. Well, in this problem, we tried to take the square root of negative 1. Up until now, we do not have a way in math to represent that answer. We've never talked about square roots of negatives. So what they did is basically invented a way to talk about the square root of negative 1. Well, what are we going to call it? They call it I. That's the symbol for the square root of negative 1. You can't prove why that's true. It's like trying to prove why parallel lines don't cross. You can't prove that. The fact that parallel lines don't cross is a basic premise on which geometry is built. It's a fact that you start with and you don't prove why. You've got to have some facts that you just don't prove and you start with them. This is one of them. I equals the square root of negative 1 because we don't have a symbol for it and somebody decided to use the I symbol. Now, once we know that I is the square root of negative 1, we can do other things with that and we can prove them. If I took I, which is the square root of negative 1, and I square it, what's the square root of negative 1 squared? We get negative 1. And I can prove that because when you square and square root, the symbols cancel, and you are left with the number that is underneath the square root. I and I squared are the only two you need to know for today. So the important thing here is if you ever see I squared come up in a problem, you cannot leave that. I squared always has to be changed to the number negative 1. Always. And the other thing to understand about I is in the English alphabet, I is a letter. When we talk about I in this lesson, it's not a letter. I represents the square root of negative 1, which is a special kind of number called imaginary. And it's the same idea with this. If you wrote that symbol, what is that symbol? That's the pi symbol. In the Greek alphabet, it is a letter that they use. But in math, we never use that as a letter. Like you'd never do a word problem and pick that as a variable, because that has a meaning in math. What is the meaning of the pi symbol? Right, it stands for the number 3.14. The same way I stands for the square root of negative 1. Okay, so it's the same idea. Yes, these are letters in the alphabets they're used in, but in math, they're just symbols that stand for a number. We do not use them as letters. So that's important to understand. Now, let's take the equation that we just had, y equals x squared plus 1, and let's plug I in for x. Watch what happens. We would have I squared plus 1. What did we just say I squared is? Negative 1 plus 1. What's negative 1 plus 1? 0. So when I plug I in for x, I get 0. What does that mean I is? If we plugged it in and we got 0. Yep, it's a root, exactly. I is one of the roots of that equation. What's the other one? Well, I'm going to show you how you find that in a little bit. But I is one of them. Anything that you plug into an equation and it gives you 0 is a root. Just this is an imaginary one. There is no real number you could ever plug in here. And we proved that. We looked at the graph and we saw that it never crossed the x-axis. So when we write complex numbers, it's kind of like how the calculator shows it don't know how well you can see it right here, that a plus bi. That's exactly the same notation that we're using. The a stands for the real part of the number, and the b is the imaginary part. So if I was looking at this one that I just circled in blue, and I asked you what is the real part, you should say 2. If I said what is the imaginary part, you should say 3. That's it. Just 3. So some numbers have a real part and an imaginary part, like this one. The real part is 2/5. What would be the imaginary part here? -1. Try to make my ones and my i's look different, because that can get confusing. Now, some numbers have a 0 for one of the parts, like this one. 3i, that's a pure imaginary number. The reason it's called a pure imaginary number is because the real part is 0. Same thing with this one. That's a pure imaginary number because the real part is 0. This one is just called a real number. You could think of it as 4 plus 0i. When the imaginary part is 0, we normally don't write it. We just write down the number 4. But technically, it has an imaginary part that is 0. So that's the 2 parts to a complex number. Real part, imaginary part. So complex numbers are like the big category. Those include everything. And then from there, we break them down into real and imaginary. And then I think it was maybe the first week of school, I broke down real numbers for you into like rational, irrational, integers, counting numbers, things like that. Okay, so what we want to do is look at one example of adding, subtracting, multiplying, and dividing, because that's all going to come up when you find roots. And if you don't know how to do arithmetic, you can be good with the synthetic division and the long division and all that stuff, but you'll get stuck with all the arithmetic, which is the easy part. So when you are combining like terms, even though I is not a letter in math, we can treat it like a letter in terms of like terms. So if you had 2x plus 3x, what would that give you? That would give you 5x. So what about if you had 2i plus 3i? Even though the I is not a letter, we can still treat it the same way. What do you think that would be? That would be 5i. 5 times the square root of -1. You do not write square root of -1. You always write I for the square root of -1. Okay, when we get into multiplying complex numbers, we're going to have to do double distributive property, or FOIL. It's going to be very similar to something like this. If you can multiply those two things together, then you'll be able to multiply complex numbers together. When we divide, we're going to have to use conjugates. The problem with division is it's going to leave an I in the bottom of the fraction. You're not allowed to do that. So we have to fix when there's an I in the bottom. And the way we're going to fix it is a conjugate. So I'm going to show you what that is. Now for square roots. Let's look at what happens when we take the square root of a negative number. Okay, I'm going to show you kind of the long way, like the full way of what happens this time. And then in the future, hopefully we'll see a shortcut. What number is in front of x here, even though there isn't really a number written?
-1.
Right, it's just like writing that. And the reason I'm going to write it like that is because when you have two things multiplied under a square root, you can separate each one of them into their own roots. Like that. Now, one of those we can simplify. The square root of negative 1. What did we say earlier? That the square root of negative 1, what's the symbol for it? I. So that would be the final answer. So the point is when you take the square root of a negative number, the negative comes outside of the root and turns into an I. And the reason why, that's what I tried to show you right there. So a negative under the square root comes out in front as an I. Now, you might be looking at me like, wait, I thought you told us when we write complex numbers, the I comes after the number you write, like 3I. The I is after the 3. Why do you think, like if I had this, and I wanted an I with it, why do you think with a square root, I would put the I in front?
Because it looks like it's in the square root.
Yeah, that looks confusing. The I isn't supposed to be in the square root. It's supposed to be like this. If you put the I in front, there's no confusion that the I is not under the square root. Now, when you don't have a square root, then it's perfectly fine to put the I after the number, because there's no confusion about the root symbol, because there isn't one. So any question when you should put the I before or after your number?
Could you just put that together, Y again?
Just because we don't want to confuse the I being under the square root.
Okay.
Yeah. So let's try this one. Square root of negative 4. Anyone think they know what that one's going to come out to? Yeah?
2I.
Right. The I comes out, so you could think of it like this. But you don't need to leave it as the square root of 4 because that simplifies to 2. So you're left with an I and a 2. And the standard way to write that is 2I. How about the square root of negative 9? 3I. Yep. All right. How about the square root of negative 7? Yeah. I times what? Square root of 7. Yep. So that 7's a prime number. You can't simplify the square root. So all you can do is bring the negative out in front. And how about this one? If it was square root of 20, you could break that down. So you need to break that one down just like it was square root of 20. But there's also going to be an I in your answer. Anyone think they know how that one breaks down? Yeah?
4I square root 5.
No, not quite. How do you break down the square root of 20? What would you
That
put?
would be 2I square root 5.
Yeah, because that would be a 4 and a 5. So the square root of 20 is 2 root 5. Well, this is 2I root 5. And where you're going to see these square roots come up, where you have to simplify them or reduce them like we just did, is when you do quadratic formula. It's going to be in this part right here. You're going to end up with a square root. And if it comes out negative, you're going to have to turn it into something with an I. But we'll get to that when we solve roots with quadratic formula. So that's important to know. The other thing that it's important is arithmetic. Add, subtract, multiply, and divide. Let's start with that. Adding and subtracting are the easiest two. Because when you add and subtract complex numbers, think of it as combining like terms. You can combine real numbers with real numbers and imaginary with imaginary. You cannot combine a real and imaginary. You can't say like 4 plus 5i is 9i. You can't do that. So if I add my two real parts, what would I get in the final answer? I get 11. And what about if I combine my two imaginary parts using addition? Negative 3i plus 5i is 2i. Okay, so that's just adding two complex numbers. Subtraction, very similar, except think of this negative is being distributed. You're going to subtract the 6, and you're going to subtract the I from the first part. Yeah? Yeah, just sign up. Anybody think they could tell me the answer here? Yeah? Okay, so the real part is 4 minus 6. There's your negative 2. And negative 2i minus 1i. Negative 2 minus 1 is negative 3. Good. Okay. Any questions on subtracting? Okay, so now the last two before we get into finding roots are multiplying and dividing. You know that this is multiplication because you don't see a symbol between the parentheses. If you see a symbol like that one, that's addition or subtraction. That's multiplication. Okay, so we're going to do this using FOIL. Some people might learn double distributive property. Multiply those together first. What's 2 times 5? 10. 2 times negative I?
Negative 2.
5 times 3i? 15i. And now let's take the last part one step at a time. It's a positive times a negative. So let's start with that. What's a positive times a negative?
Negative.
It's a negative. So we've handled the sign. So now what's 3i times 1i?
3i squared.
3i squared. And it's negative because it was a positive times a negative. Okay, first we've got some like terms. What's negative 2i plus 15i? 13. So 13i. Now we have an I squared. Okay, we never want to leave I squared. What does I squared change to? So that changes to negative 1, which really means we have negative 3 times negative 1. And that's going to give me what? Positive 3. And now you can combine that with something else. So what's going to be your final answer here?
13 plus 13.
Yep. Just a coincidence that the real part is 13 and the imaginary part. That doesn't have to happen. Okay, but that's multiplying. Distributive property. Questions on that? Okay. So, yeah.
Does the imaginary part always have to be behind the real number?
Yeah, it should always be in standard form, real, then imaginary. It's not technically wrong if you don't. All right, so now the last thing we're going to talk about is division. But to do division, we have to first talk about a conjugate. So a conjugate, very simply, is when you take the imaginary part of the complex number and change the sign. If it's a negative, you make it positive. If it was positive, you make it negative. So if you had a complex number a plus bi, the conjugate would be a minus bi. The real part stays the same. The imaginary part has the sign change. So let's just practice looking at a number and see if you can tell me the conjugate. What would be the conjugate of 3 plus 2i? 3 minus 2i. How about the conjugate of 4 minus 5i? 4 plus 5i. How about the conjugate of 3i? Negative 3i, yep. And the conjugate of 6. What would it be?
It would just be 6.
It would just be 6, yeah. Because 6 doesn't have an imaginary part. So you could think of the original as 6 plus 0i. The conjugate is 6 minus 0i. The same thing. So, any questions on how to find a conjugate if you have a number? Okay, now, the last thing is using the conjugate to do division. So in order to divide two complex numbers, we don't actually divide, we multiply. And what we do is we multiply the top and the bottom by the conjugate of what's in the bottom. So to divide two complex numbers, multiply the top and the bottom by the conjugate of what's in the bottom. So what's the conjugate of the bottom? And that's what you're going to multiply the numerator and the denominator by. 2 plus 3i. Any questions on why it's 2 plus 3i? Now, something very nice happens when you multiply conjugates together. I can tell you right now, the bottom, when you do that all out, it's going to come out to 13. And there's a very quick way you can multiply conjugates in your head. We're going to FOIL it, and then I think you'll start to see what happens. Unfortunately, in the top, there is no quick way. You just have to do the whole thing out and see what happens. Okay. So 5 times 2 is going to give me 10. 5 times 3i. Okay, I'm just going to put that off to the side for a second. 15i. 2 times i. 2i. And combine 15i and 2i.
17.
So it's just one less thing I have to do later on. Now, positive times positive is a positive. So we took care of the sign. What's I times 3i?
3i squared.
3i squared. Okay. A few things we have to do in the top. We'll come back to it. Okay, the bottom. Okay, watch what's going to happen here. 2 times 2 is going to give me what? 4. Now, what's 2 times 3i? 6i. What's 2 times negative 3i?
Negative 6.
When you're multiplying conjugates, as long as they're set up in standard form, like that, the outer and the inner always cancel. So you don't even have to do them. Now let's do that part. Negative times positive is a negative. What's 3i times 3i?
6i squared. No, 9i squared.
9i squared. Now remember what I told you the bottom was going to be 13. Let's go to the next step. I squared is really what number? So in the top, you have negative 1 times 3, which is how much?
Negative 3.
Negative 3. And in the bottom, you have 4 minus 9 times negative 1. Well, you're subtracting a negative, so those are going to cancel and become a positive. And what's 4 plus 9?
13.
Now let's simplify the top. When I combine everything I can, what do I get in the top?
7 plus 17i.
7, good, plus 17i. And that's almost there, but that's not standard form. If they ask you to write your answer in standard form, you need to have a real number, plus, or it could be a minus, in this case it's a plus, imaginary, and then an I next to it. What do you think would be my real number?
Is it 7 times?
7 over 13. So the real part is 7/13, and the imaginary part? 17/13. That's how you write your final answer in standard form. It has to be two separate numbers. And if this was a fraction that reduced, like let's say it was 7/14, then I would reduce 7/14 to what? 1/2. It's 1/2. But 13 is a prime number, so it's not going to reduce. Okay. So that's the review of adding, subtracting, multiplying, and dividing. Any questions on complex numbers? So now, any of those things that we just did could come up in this problem. We're just going to find the roots, and if they come up imaginary, now we know how to deal with imaginary numbers. Okay. So to find the roots, what do you set that equation equal to?
0.
Set it equal to 0. Based on the exponent, based on the highest exponent, what kind of equation is that? That's quadratic. When you have a quadratic, do we have a formula to solve quadratics? Or do we need to use rational root theorem and synthetic division? We have a formula. We call it the quadratic formula. So we can jump right to quadratic formula. There is no need to use synthetic division or rational root theorem if you have a 2 in that spot. Remember. If you have a number that's not a 2, then, well, we'll look and see if we do one like that. Okay, what's A in this case? 1. B? 1. C? 1. Okay, so fill that all in. Negative b plus or minus the square root of b squared minus 4. You tell me what's next, because I see some people messing this up on tests. AC. And then what's after that?
It's divided by 2.
All. Not sum divided by 2a. That was a mistake I saw in a test. All divided by 2a.
You should sing the song next to be able to sing.
She has a song.
That's still.
Yeah.
It's like. We should have her come in here.
Maybe I'll have her come in.
It's like x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a.
Oh, wow.
Yeah.
Okay. Well, there you go. That helps remember it. Yeah, whatever works. Okay. Now, what are we going to get under that square root? 1 minus 4 is what? Negative 3. We have to clean that up a little bit, and this is where we talked about square roots of negatives. What is the square root of negative 3? I square root of 3. So that way is perfectly fine to leave your final answer. If they ask you to write it in standard form, then no, that way is not fine. In standard form, you would write negative 1/2 plus or minus root 3 over 2 I. Now, you might say, well, wait, why did you put the I after the square root? I thought you said you shouldn't because it could look confusing. Well, at least to me, it doesn't look like that I should be under the square root because now the square root is in a fraction. It's not like I have something like this. That's different. Now I can't really tell where the I goes. But when you have a fraction, and you put the I right in the middle, it's perfectly fine to put it after. Okay, so this is the same answer as that, but this is called standard form. The one up there is not standard form. Is there any question how I changed that to that? And technically, if you put the I before it, I mean, it wouldn't be wrong. It'd still be right. It's just in that situation, you usually see the I after. That's kind of the custom, the way it's done. And that's it. Those are the roots. So look at the two roots that we just got. Negative a half plus root 3 over 2i. Negative a half minus root 3 over 2i. What do we call that when the sign of the imaginary part changes? Conjugate. Whenever you are finding roots and they come out to be complex, they always occur in pairs. Always. You can never have an odd number of complex roots in a problem. They always come in pairs. And not only do they come in pairs, they come in conjugate pairs. So if you know 3 plus I is a root in your problem, then 3 minus I is automatically a root. So imaginary roots always occur in pairs, and the pairs are conjugates. So if A plus BI is a root, A minus BI is a root. As long as B isn't 0, because then if B is 0, you wipe out the I part completely. And then what I just said here doesn't make sense. Okay, so all the things that we've been working with all week, they still work. Remainder theorem, factor theorem, synthetic division. You can still use them. So here, I'm saying something kind of important. If a polynomial has an odd exponent as its highest exponent, it will always have at least one real 0. What does it mean on a graph when you have a 0? Crosses the x-axis. So another way of asking that same thing here is, why do odd degree polynomials always have to cross the x-axis at least one time? Even doesn't. Think of a parabola. A parabola is a U-shape. You could have a U-shape that never crosses the x-axis. But why do odd degree polynomials have to cross the x-axis at least once? Yeah?
Because the end functions are always opposite. One
Right.
going up, one going down.
The end behaviors are opposite. One end goes down, one end goes up. Could be down, up, or up, down. But when you sketch them, one end goes down forever, one end goes up forever, and you never lift your pencil when you draw it. So if you go down forever and up forever, you're going to cross the x-axis somewhere. And if you cross the x-axis, that means you're going to have a 0. So looking at this problem, x cubed minus 1, will it cross the x-axis? Yes, absolutely. It is an odd degree polynomial. It has to cross the x-axis at least once. And we have to use that fact to help us. Because the highest exponent is a 3. Can you plug that into quadratic formula? No. That's not a quadratic, that's a cubic. So the only way that you're going to be able to solve this problem is if you can turn the cubic into a quadratic. And we have to do that with division. But I don't know what I should divide by. There's lots of numbers out there. How am I going to get a list of possible numbers that could be roots?
Things.
I talked about it yesterday. What is it? Factors?
Oh, possible rational root.
Rational root theorem. All right? So I could add that to the list. Rational root theorem also works. We're going to have to use the rational root theorem as a starting point to find the number that we should divide by synthetically. Once you find that number and divide by it, it's going to take this exponent and it's going to drop it down 1. Once that exponent drops down to a 2, then we're fine. We can use quadratic formula. So let's start with our P's and Q's. What are all the factors of my constant in this case?
Plus minus 1.
Yep. So the constant is -1, and the only numbers that divide into that are plus and minus 1. What are all the factors of the Q, which is the number in front? It's also plus or minus 1. So if you take all the P's and divide by all the Q's, you're going to make that list. What would be all your different options for this problem?
Plus minus 1.
Just plus or minus 1. That's a very small list of options. In fact, that list is so small, and this formula is so short and simple. I can plug these numbers in one at a time faster than graphing it and looking at the calculator. Let's just try 1. If you plug in 1, what's 1 to the 3rd power? 1. And then take away 1?
0.
There you go. So we just found the number that you can plug in that gives you 0. If you have more options or that formula is more complex, that's when you would graph it, look at it, and eliminate the ones that don't make sense. That's what we did yesterday. Okay, so we know 1 is a root. What am I going to do with the 1 now? Yeah?
I forgot what it's called when you put it in the kind of half box and then you.
Synthetic division, yeah.
That's what it is.
So now that we know 1 is a root, we're going to divide through by the factor that gives you that root. That's going to turn the cubic into a quadratic. So let's divide through. We're basically going to divide that problem by x minus 1. Because this is what I'm trying to figure out now. I know that 1 is a root. That means this is a factor. I don't care about that. I already know that. I want this. I need to know the other factor. So to get this other factor, we're going to divide each side by x minus 1. Okay, well, we're going to do it with synthetic division. So put the 1 on the outside. What would be my numbers on the inside?
1, 0, -1, 0, -1.
1, 0, 0, -1. Forget the zeros. It will come out wrong. So you got to put the zeros in. Okay, bring down the 1. What's 1 times 1? 1, and then add that up. Multiply again. Add that up. Multiply again. And add that up. 0. I already knew that. I knew I was going to get a remainder of 0. But now I know the other factor. It's x squared plus x plus 1. So I've already set the first factor equal to 0. What did I get when I did that one? 1. I already have that. Now I need to set the second factor equal to 0. x squared plus x plus 1. And now I need to solve that. And those are my other answers. But look at what we have. X squared plus x plus 1 equals 0. X squared plus x plus 1 equals 0. We've already solved that problem. When you solve that problem, that's what you get. So now in the problem that we're doing, you would need to do what we did right here. So the other two roots are negative a half plus or minus root 3 over 2i. So negative a half plus or minus 3 over 2i. What example was that? Example 4. That's how we did it. So the biggest thing is you have to find a rational root to start the whole problem off. If you couldn't have found one, we would have been stuck, at least with what I've taught you. You wouldn't have been able to solve it. Yes?
So it's a plus or minus pi, not just a plus pi?
No, it's plus or minus, because when you do quadratic formula, we're copying down the plus or minus from the quadratic formula. That's where that is coming from right there. Any question on that? Okay. So let's try. Okay, so let's just look at a pattern. Let's look at the last example. What was the highest exponent in that problem? 3. How many roots did we get? 3. Right, there's 3 roots there. So the exponent was a 3. We got 3 roots. How about when we did this problem? What was the highest exponent? 2. How many roots did we get? 2. So the number of roots that you get, the number of answers to the problem, is always equal to the highest exponent. If there's 4 roots, the exponent on the problem is a 4. If there's 3 roots, the exponent on the problem must have been a 3. 2 roots, it must have been a 2. Those two numbers are always the same. And that idea also ties in with factors. Because remember, each root comes from a factor. If 2 is a root, x minus 2 is a factor. If 5 is a root, x minus 5 is a factor. So when you go to factor a polynomial, you will always have as many factors as the highest exponent. It's really the same thing as saying you'll always have as many roots as the highest exponent. Because roots and factors are the same thing. So if I were to try to factor this cubic, how many factors, how many sets of parentheses would it have when I'm done?
3.
It would have 3. How many roots would it have when I'm done? 3. How many zeros would it have? 3. That's how it would factor. Now, I couldn't just look at that and do that off the top of my head, but at this point, you should be able to take that and turn it into that. You would have to do rational root theorem, find one that works, then divide through synthetically, and you'd have a quadratic, which then you could use quadratic formula on. How about if I had something with an exponent of 5 as the highest exponent? How many sets of parentheses would that have when I factor it? It would have 5. Now, when you write 5 sets of parentheses, if the highest exponent was a 5, the parentheses do not need to all be unique. You can have ones that repeat. Like if you were to do this problem, that's going to factor, but it's going to factor into 2 things that are the same. That still counts as 2 factors. 1, 2. they're just the same. So when you write down your answer, there's only one number that you can plug in here. This problem would be -1. This problem would be -1 and what other number? 2. So the way we could say that is the word multiplicity. That tells you how many times the answer repeats. So -1 is a root, and it occurs twice. So we say it has a multiplicity of 2. 2 is another root, and what would be the multiplicity of the number 2? 3, because it occurs 3 times. Any question on that? Okay. So, last question, deciding, do I want to do this one or am I going to switch it? No, I'm going to switch it. The last question is going to tie in with something we mentioned yesterday. Let's say that your roots were 5 and -2. What would be the factor that 5 came from? It would have come from x minus 5. And what would be the factor that -2 came from? X plus 2. So if you know the roots, you automatically know the factors. The factors are always this form. X minus, and then fill in what your root was. Now this one was -2, so it's x minus -2. That's why it became plus 2. So now let's do the same thing with this. I want you to find a polynomial that has a root of 3 plus 2i. And I'm not going to tell you the other root, but you should know what it is automatically based on the first one. That's an imaginary root. How did I say imaginary roots always come in what? They always come in pairs. So what would be the other one that has to be with that one?
3 plus 2i.
Well, we got 3 plus 2i.
3 minus 2i.
3 minus 2i. So now, I want to do the same thing you did up above. Tell me what the factors would be.
3 minus 2i.
X minus what? 3 plus 2i. That's x minus your root. And what would be the other one? 3 minus 2i. X minus your root. And now we need to simplify. What's in front of each set of parentheses that could be distributed? A negative. So let's do that. Minus 3 minus 2i. And what about when you distribute the negative in this other one?
X minus 3 plus 2i.
Minus 3 plus 2i. Now, you've got 3 terms here. You've got 3 terms here. You have to FOIL that. When you have 3 and 3 and you FOIL, it's 9 steps. It is 9 things you have to multiply. Okay. And I'll color code them 3 at a time. Let's start with distributing the x to everything. That's the first one. What's x times x?
X squared.
X times -3.
-3x.
And x times 2i.
2.
2xi or 2ix. Okay, so that's the first one. Okay, second one. We're going to distribute -3, -3, and -3. What's -3 times x?
Negative 3x.
Negative 3x. What's negative 3 times negative 3? 9. And what's negative 3 times 2i?
Negative 6.
Negative 6i. So that's the second one. And now the third one. We're going to do that times that and times that. What's negative 2i times x? Negative 2ix. What's negative 2i times negative 3? Positive 6i. What's negative 2i? Let's start with this. What's a negative times a positive?
Negative.
Negative. And what's 2i times 2i?
4i squared.
So now, looking at what we have there, some things are going to cancel. Does anybody see something that cancels?
2ix.
6i.
2ix and,
6i.
well, what is it? What does that cancel with?
The negative 6i.
Negative 2ix. What else cancels?
The 6i and negative 6i.
Positive 6i, negative 6i. So out of the 9 multiplications you just did, 4 of them are gone. That will happen every time. So almost half of them just disappear. Basically, anything that has an I in it disappears. If it doesn't, then you did something wrong. Okay, you should not be left with any i's. So now we have x squared. What's negative 3x minus 3x?
Negative 6x.
Negative 6x plus 9. And now this part. What is I squared?
Negative 1.
So that's x squared minus 6x plus 9. And what's negative 4 times negative 1?
4.
Plus 4. So what do we get for our final answer?
X squared minus 6x plus 13.
Now, if you had to check that those were the roots, you'd use quadratic formula. And then you'd be reversing everything we just did. If you use quadratic formula on that, the two answers should be 3 plus 2i and 3 minus root 2, 3 minus 2i. I'm not going to do quadratic formula. So that's how you find a polynomial with imaginary roots. So let me just double check. 1 through 3 and 9 through 13, that's all arithmetic. Add, subtract, multiply, and divide. So is actually 15. 19 to 22, that's okay. Let's see, we're going to skip 32. 36 is like the one that I just did, but I'm going to change it to 35. So that's like the one we just did in class. And then 39 and 40 are yes or no questions. So I'm going to leave that up, I'm going to pause it, and I'm going to try to put up the test topics while you guys are here, if I can. All right, just a reminder too that I am after school today for extra help.